Thank you. Hello, everyone. Dmitri Zimine. I'm here to talk about automation and one particular type of that once was very hot and then was, falling out of the hype, and now it's coming back again. And to me, this is a personal journey. A decade ago, I was with the company, Apalis, where we created the runbook automation. And this later became Microsoft System Center Orchestrator. So I know these legacy tools very well, and because I built some of them, and I know what's wrong with them and how they're broken. So I'm, in fact, on a mission to get it all right again. Was with Apalis, then I'm contributing to OpenStack. We're building the Mistral, which is the OpenStack workflow service. I founded the company StackStorm, and we built the event-driven automation system, open source one for DevOps. And then currently, as Brocade and StackStorm are together, we continue to run StackStorm, event-driven automation platform, and apply that to networking, among other things. So today, I'll just go over the brief history of the workflow-based automation, tell you how it works, how users benefit from that, and when we dive into the details, we'll show a little bit of how these workflows look like, and compare and contrast that with alternative ways of automation. So automation starts with workflow, and workflow is just the set of the tasks or activities that are string together to achieve the meaningful business objective. And it all begins in business automation. So there was a whole bunch of books, and Georgia, this is our host, is author of one of the books. The body of knowledge on the workflow created when there was an idea of why don't we apply software to automating business processes. The computer science body of knowledge has been created in the late 90s. All this workflow nomenclature, patronets, workflow management coalition, workflow patterns, BPL, BPM, it is all from there. A number of business process management tools has been created. You are still enjoying using some of them when, say, like you're doing the expense reports or some, procurement or sales. But the problem with business processes is people don't respond well to automation. And someone smart, I believe that was Tipka at the time, they say, well, look, we have this business automation suite. Why don't we apply that to computers? Maybe computers will be better than humans when it comes to the automation. They'll behave better. So, and that's what we did. And after that, a number of the startups came up. They were like literally like mushrooms under the rain. And just by the show of hand, anyone is familiar with any of them? I mean, they'll probably be there for a year or two. There was a huge hype. This is the Gartner hype cycle, and it is 2008. And what you can see there is runbook automation become there as a big and hot thing. What's also interesting here is that the configuration management had been there, but it was already going down to the turf of disappointment. An interesting observation is the history repeats itself. We already have the configuration management with Chef, Puppet, and all the other guys as a commonplace, and the runbook in newer incarnation is coming back again. So that was a hot topic for some time, and then, however, after a kind of quick series of acquisitions, all these companies disappeared and became part of the big suites. And it hurts me to say, but these projects, although they've been using in traditional IT, when you go to the service providers, you go to Twitter, Box, Slack, Uber, to all the, you won't find any of that type of automation anymore. And they effectively, the big operational suites become shelved there. Beyond the traditional IT. The thing is, the problem that they used to solve is still there. In fact, the problem is bigger than it was before. Things are going much faster. It took a week to provision a service 8 years ago. In funny, some places it still takes a week, and takes the tickets and documents flying together. Right now, you start the Docker container in microsecond. Like tools, we have ways more tools. We typically deploy to 3 to 6 clouds. There is a recent research from RightScale, and if you believe them, a company uses 6 cloud platforms on average. On my last count, the monitoring tools, there are just 140 monitor tools alone. We measure everything. We apply analytics to that. We apply machine learning to that. And but then when the alert hits, we're back to the old good things. There is an alert, we take a look at that, and then switch back to kind of roll up the sleeves and do the manual interactions, or sometimes just run the scripts at best. I mean, the problem is big, and the big ones, all the hyperscale guys have figured that already out. Facebook is here because it's probably the most vocal of that. Like the F-bar notably saves 13,000 hours a day in operational cost. There's the head of SRE in Facebook, Pedro Canahuati, was giving this talk in the SRE conference, I think last year or the year before, and he confirmed this incredible number. We're friends with them. We know how they run the infrastructure. It's actually the only way the team of 10 people there would run this incredible number of hundreds and hundreds of services. For them, as Sebastian is, there is no other way. There is a number of other tools like that. I will focus in my further talk on Mistral and StackStorm, and 3 reasons. First, I'm biased. Second, I know them, so it's easy for me to use them as examples. But third and most important, they're open source and Apache 2 license, so when you come home tonight after the dinner, you can download them and give them a try. So, how is this thing built? The key ingredients for that is the system, first of all, assumes that there is already the data center, existing tools, existing cloud, networking, storage, and it sits on top and provides the higher level orchestration. And it does so by first providing the sensors and actions. And sensors are things that are responsible for inbound integrations, and actions are things that are responsible for outgoing integrations. Typically, that's just a piece of the code. And the sensors sense the event. The event is most usually a monitoring system event, but it might be as well a temperature in this room. And when the event fires, it goes into the trigger, and the rule engine says, well, if this happens, then what do I do? And depending on the rules, they're very simple rules. Here is the event, here is the payroll, here is the criteria. Let's run this workflow. And the workflow is the thing that is stitching together the atomic actions across different domains, and it does 3 things well. It keeps the state, it unifies the data, because data come in very different forms, and it keeps the business logic. When do you run this and this? And I'll just illustrate that with an example. And the example is very simple remediation. This is the the log management, the thing that happens shamefully more often that we admit. In fact, when we came to work with Netflix and we say, okay, let's do some remediation here, what do we do first? I say, look, we are paged with the service, our Jenkins service, running out of the disk space so often that we don't have much time to do remediation. Let's first fix this problem, plug this hole, and then we get to more serious stuff. So this is an example where we assume that we have service, and there is a monitoring tool, Sensu in this case, that is checking if we are running out of the disk space. And the service fires the low disk alert. Then it goes into the system, in this case StackStorm, and creates the trigger. The web service, Web03, is low on disk space. Then if it is something known, like the disk space, then it checks the situation, and if the service can auto-remediate itself, it's some known problem, it is, okay, it's logs. Well, If logs, we can just clean up the logs and turn out the log rotation again, keep on going. Then we can fix this problem. If it is some genuine failure or something else, wake up the administrator. So pretty simple. Well, with this set of sensors, rules, triggers, events, what can be automated? Well, the easier thing is what cannot be automated. Everything that human can do and everything that requires us to carry things between different domains and different tools is a good use to this system. There are some other things that we put here, and it's not just the remediation, it's also active security responses. It is also some interest in application deployment. I always joke that Jenkins is a good tool, but when you begin to use that to configure load balancer, you stretch that too far. Networking, some provision networking are just too, they're simple. There is no intrinsic complexity there, but to do that manually is almost impossible just to the probability of fat fingering something. So doing the things, and when we look at, this is the from the book on the practice cloud administration. So we go after something that are easy to automate and happens frequent. And I'll just make a note here on easy to automate. In reality of the enterprise, there is a number of systems which have poor API or no API. And I don't consider them as hard to automate. It might be labor intensive, it might be, but there is no intrinsic complexity there. And the sort of the good event-driven automation tool will help you with this. Because the fact that it is, the difficulty, dealing with difficult API don't qualify as an excuse not to automate, deal with this. So, in fact, that type of the system right now, they're probably less sexy than machine learning. That's like a bunch of duct tape. Once you have it, you find a lot of usage for this. Specifically for runbook automation, specifically for remediation, the type of the benefits are sort of obvious. First, sometimes when you remediate at computer time, not the human time, you can avoid a failure altogether. Because by the time someone wakes up, it's too late. Even if it is not the case, reducing the time to remediate the failure is very important. And Netflix is actually driving this point home. This is from Netflix presentation. In fact, today and tomorrow, there is a QCon conference in San Francisco, and they present in their their stuff on how they're remediating stuff. The timeline here is pretty obvious. It's all serial, and it all takes time. And without automation, they say it's about 30 minutes for a simple case, like clean up the logs. And when they do that with Winston, that's their version of the event-driven automation tool, they reduce that. What's interesting here is 3 typical patterns. One of the pattern is runbook automation pattern is remove false positives. This is very simple, and that can always be automated. Another one is the simple problems with the simple solution can be just fixed automatically. And those problems that don't need that are more difficult to fix, at least can be done with what they call, or we call, assisted diagnostics, which is when you wake up, the first 5 things you check are like that 5 things. We can make the system, in that case Winston, do these checks for them, and when the administrator comes, the results of these checks are already available for them. In fact, it has some interesting meaning to the monitoring, because sometimes monitoring is expensive. And one strategy on monitoring is to monitor everything. Another strategy on that is relatively lean monitoring with running some extra tests and getting some extra information when like on per need basis. So the other interesting users of Fujitsu, they actually shared the slide with us, and it took us a while to translate. So they, what I like about these guys is they measure everything. They begin to run stack storm in operations, and they, as you can see here, it's a variety of the benefits. And on this variety of the benefits, there is important kind of good results. Mirantis, Barcelona, 2 weeks ago, they're presenting how they run a similar system that actually runs TechStorm on semantic cloud. I think 2,000 nodes, relatively big OpenStack cloud. And what they brought up is the team impact. You know, the presentation was called Sleep Better at Night. They talk about the positive team impact on that. We hire very expensive engineers to run the cloud. You don't want to burn them out. I mean, it hurts. And there are other things. It's usually operations are reactive. To turn them to proactive, to break from these vicious coils, you need to deal with the low-hanging fruits. And the more you deal with that, the more time you have to spend time on serious things. Last but not the least is capturing operations, and capturing operations as code. I will return to this, but you know, this has part of the team dynamic, and knowing how exactly we react to known things in the ways that are better than documentation, that is like not up to date, is also very important. Okay, so I'm halfway and about to get into the details, and in details we'll talk a little bit about the workflows. I'll show you some of the workflow patterns and give you an impression, you know, what these workflows are and how they look. And I'll be using Mistral as a question, so that when I get to comparing and contrasting the workflows, you'll have a better sense of what I'm talking about. So, event-driven automation is more than workflows. Just workflows is a very important, at least in our mind, a very important component of that. The body of knowledge on the workflow system says that there is a kind of number of patterns, and again, we have experts in the room on that. My practical experience is, and I like in my past life and right now, I saw a lot of workflows run in automation. Is only few of them are necessary and sufficient. And I'll just go over them and we'll see what they are. And the basic of one is the sequence. And this is the typical remediation thing. You update the configuration and then clean up the log, restart the service. One after another after another. I use the Mistral syntax here, and you can see that it is pretty readable. It says here's a series of tasks. Each task has a step name, and it has associated action, and its input parameters, and what do you do after. So pretty simple, right? So next pattern is data passing. Just running this action is not interesting. In this example, we run the diagnostic and say we want to dump that in some shared communication tool like Slack. So we can use the data from the upstream actions directly, or for convenience publish them as a variable. As a result, we pass the data from the upstream tasks to downstream tasks. Basic conditions of deploy application on success, post a failure, on failure, kind of page administrator. Again, very basic. Conditions on data, very typical. One of the first one, like change, for instance, checking the switch. It might be just a simple script, and we can base the conditions on the exit code from the script. Again, we use the data from the previous tasks, and we switch the conditions on that. And interestingly enough, this is it. Like, this is probably the minimal of the operational patterns, and you can see some of the workflow solutions out there. They just make it enough. Like Nurse, for instance, the one that LinkedIn is running is. That's pretty much where they stay. Well, this is sufficient, but this is not kind of, we can do better than that. There are a few others which I think that make that not only doable, but also convenient. For instance, parallel execution. We continually deploy and test TechStorm in our we eat our own dog food. We run that on free operation systems, and we run the tests on free operation systems. I don't want to do that kind of sequentially. I want to do that parallelly. The thing with that is joining. Once you break this hunky-dunky, putting that back together is pretty difficult. In fact, it is apparently, I forgot the number, there are 16 ways of joining this hunky-dunky back together again. And depending on these different 16 ways, there is 16 answers on the simple question. And the question is, how many times the T5 task will run? So, again, our learning is we can only use the subset of that. And what we say is simple merge. Simple merge is after every task, just report the result. The T5 will run 3 times for every upstream execution. And join. Imagine that I'm running the tests on 3 operation systems, and I want to say success. I only say success when all of them has completed successfully. And I'll be waiting for all of them, and I only want to say success once. For instance, I want to tag the release at this point, don't want to tag the release multiple times. So this full end join will wait for all of these tasks to come with success, and then this join all is the feature in Mistral syntax that forces that. I'm wondering if I'm losing you on that, so to get it more different. But on the other hand, if we're failing, if we fail in the test, then I don't need to wait for all the others to complete. I already know that there is not going to be a release. So the first one, I also want the T5 to run only once, saying, guys, we failed. Only once, but I can easily ignore the rest. It's just, we're done. I don't even want to even wait for them. You know, these patterns is, if I'm kind of remembering that correctly, is called discriminator, and the name is probably because US legal people didn't review the language of the patterns just yet. So finally, multiple data. People ask me in the workflow, can you do loops? Can you? And my answer is usually, you don't want to. You can do, but again, this is most of the time when you do loop, you just have an array of the data, and you want to repeat an action for different sets of data multiple times. And for that, in Mistral, we have a particular way of doing that, which is, we say like for with items. And we say with items and give it number of arrays, and then it runs that on each element or set of the elements from the input data. The interesting thing here is you don't even see that, but it runs in parallel. And you can control the parallelism of that. You can reduce that, you know, like with concurrency 1 that makes it sequential, or throttle the concurrency to the level of comfort of the system. And with that, it's all the patterns, and I think with this you can at least get a sense of, okay, here's what we're talking about workflow. Like 6 patterns. In our experience, that set of patterns creates necessary and sufficient set for using workflow in IT operations. Now, but why not scripts? Well, in fact, workflows don't exclude scripts. It doesn't. What workflows benefit from having scripts, but they use scripts in the very particular things as actions. Stitching things together with scripts is probably easier when you say about writing the scripts. Like writing the scripts, you ask any operator, I'd much rather write the shell for that. But the problem with this is workflows are easy in operations. Workflows are transparent. It's not tune-compliant language. That's why it has very limited number of states. And the state is always transparent. So when you run that, you always know what it is. When you say, I'm running the workflow and it contains 5 steps, and I'm on step 3 and I'm failing and this is the error, finding this error really quickly in operations is essential. This transparency is important. And then the workflows are also reliable. The workflow, it's not the function of language, it's function of syntax, it's function of the workflow engine. And the right workflow engine is built with resilience. That means that in Mistral, for instance, any component will fail, but the workflow execution will continue to run. There might be failures due to the external conditions. For instance, I'm trying to call an API, and there is a network outage at this time, so that fails. We have a way to restart the workflow from the point of failure. So when script fails, then you can only pick up the pieces. So that highlights some important requirements for running the automation, because reliability and transparency is something that we always want when it gets to automation. The more interesting question is, how come that the old tools failed to address this problem? How come that, like there was a problem and people tried to solve that and we didn't come to this? And it all, I think, tracks to the history again. As you remember, they rooted from the business automation. And there is some assumptions that you make when you automate the business. And one of the assumptions is people who are doing the automation, they don't code. Well, if this assumption holds true for your infrastructure, and if you hire the people to run infrastructure and they don't want to write the code, well, technology cannot solve this problem. It's what's important right now with the new generation of the tools is DevOps. And when I say DevOps, I firstly mean infrastructure as code. Let me illustrate with an example. We have users who used to run the legacy automation tool, in this case Cisco Process Orchestrator, but doesn't really matter. Yeah? They run the automated provision use case, sort of self-service. They have 4 data centers, massive amount of VMs. I think it's 10,000 OpenStack nodes, something like that. Mixed cloud, VMware, and OpenStack. So what they had before, the workflow in Orchestrator is 140 steps. They need to do something, and it's obvious. You create a VM. Sometimes you create large VMs, like 40 VMs. You build them into the operator, but then you need to register that in all the internal tools. You need to set up the monitoring. You need to provide the DNS on that. There are some approval steps on that. It's pretty complex. The change management is a nightmare, because what they do is when they do the change, they open the GUI. They go to that, click, 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 pum, pum, pum. They press the OK and pray. And then they go to another data center, and they try to repeat the same sequence of events and clicks, and then press the OK and pray again. And they're doing that 4 times. Like, you get what's wrong with that, right? And of course, it's not the DevOps way. These guys got the mandate to switch to the DevOps. And they pick up the tools that could actually do that with, they run the whole automation in their development box. When we're happy with this, they commit it. During the commit, there is a code review. And you saw the workflows. You can imagine looking into them. It's pretty reasonable. They do the code review. They do the commit. They promote the commit into the testing branch. And that gets auto-deployed into the test environment. They run the tests. When they're happy, they move that into production in all 4 data centers, and they are sure that all 4 data centers run the same. I mean, we run the DevOps right now. For us, it's duh. But that's been a pretty big transformation of that. The point is, they won't be able to do that with the old tools. The old tools are just not built with this. I built one of this tool, I know. Jeannie Kim was just presenting the other week on Monday on Intel conference before that. And what's interesting, and one of the things that I got the most impressed from his learning, and that's relatively recent, is that the top predictor of the IT performance is not whether the developers are using source control, but whether the operators are using source control. And funny, developers are using source control all the time, and operators in traditional IT never do that. And this is the thing, we need to build the tools where the automation itself is the subject of the proper DevOps. That the automation itself plays by the rules, and automation itself can be reviewed and source controlled and treated right. So when I say design for developers, that's actually not just infrastructure as code. It's few other things. And open source is obvious, and people think it is for the control. Not really. It is. It's not for time saving. It's mainly the matter of control. You go to any sizable cloud provider and try to see the proprietary tool there. No luck. I think Splunk is probably the only exception I'm familiar, but part of the tool chain. And again, it's we building the applications. Vendors are still catching up with this, where they assume that they have the whole world. But in reality, our operations are very custom. Our operations are very unique. The way we try to solve this is very unique. And an ability to build, to mix and match the tools is essential for operations. So that's another thing. And it's pretty much I think that with DevOps, right now, the time of the big enterprise suites is over. And, check the successful DevOps teams and judge for yourself. Obviously, having open source community, as you think of Puppet, Chef, Docker, having the hub type of things where people create and amplify the stuff is essential, and that's why, again, one of the important things for us is to build the inventory of the open inventory of the integrations, because I tried that. Any vendor who tries to maintain a rich library of integrations, it's an uphill battle. And skills. For the skills, all these tools are much more demanding, and that creates a question of whom you cater for. Because if, again, I'm returning to this point, if your SREs are not capable of writing the code and you want to run your infrastructure as code, there is something wrong with this. Lastly, one point, and it's more of the opportunity. Now that we have automation, and the automation is captured as workflows and rules, and they are code, we have an interesting opportunity to share and capture the operations and share them with code. And I'll just give you an example. We're talking about the Cassandra remediation. And that's a typical use case. It's known, it's described on DataStax wiki. And when Cassandra node goes down in the ring, there is a step, there is a wiki that describes, I think, 6 or 7 steps on how to remediate that. And if you go that and follow, sure, we automated that. And when we automated that, we wrote the blog, we created the video, but most importantly, we put the code. We put the code of this automation on GitHub. I mean, it's different for everyone because people use different monitoring systems. People use different you can use, we use Slack, you may use HipChat, but the concept, the meat of that is exchangeable. So rather than writing that down, we can actually eventually, this is more of the vision, capture and share this as code so that things like how do you how you operate OpenStack, how do you do the migration on OpenStack, how do you typical interactions across the industry can be captured and somehow exchanged in this shape or form. So in summary, vendor automation works, and the workflow works with a new spin, and there are visible benefits for the operations. Automation, well, it better be reliable, transparent, these are the requirements, and infrastructure as code is the key. So, I can't hold, shameless plug for our product. OpenStack, StackStorm is open source Apache 2 license. You can get that. Its sibling, Brocade Workflow Composer, is enterprise version. Commercial edition of that is available. Questions?
Thank you.
Nobody else. So I think I've two related questions, and they are around testability and maintainability of the workflows. One of them is, how do you make sure that the workflows are testable and that they're exercised often enough that you can actually tell when they break? And the other one is that by having these workflows, you're creating a code base that is separate from the actual systems that they're automating. So how do you make sure that the systems you're automating, the changes in those systems, are also reflected in the workflows and the workflows don't get out of date?
Mm-hmm. I'll take the second one because it's easy, and the first one, which is really hard. The second one is the learnings are, there are applications and there are dependencies. And we find that, just like monitoring, the closer to the box you monitor, the better the results. Remediation is the same. The closer to the source of the failure you remediate, the better examples. We find that remediating this off-box remediation when applied to the application is probably not such a good idea, other than the temporary bandage. The right fix needs to be an application, and what is a good way to do that is, say, like, you're running out of memory, like, simple, you put up the restart that when it runs out of memory, and then the next step in the workflow is upload the Jira ticket that says that damn fix it. So that kind of it doesn't grow. But where it is widely used is on dependencies. Say you're running the application, then you're dependent on Redis, you're dependent on Elk, you're dependent on Cassandra, and there are some quirkiness with running them. And eventually they'll be fixed in the upstream. But when the group is running this type of the service, that is where the that type of automation yields the best results. And in this case, it's more the it's separated from the application. To the second question, testability of the workflow. This is a tough one, and I don't see that it has a good solution, a final solution in the industry, just like the testability or the configuration management deployment tools. The partial solutions to that is implementing the dry runs and mocking and dry running the workflows, just as you do with unit testing the code, and running that in the pre-deploy environment before promoting to the deploy environment. Especially the corner case conditions are here difficult to test. And this is known problem. We these are the only two solutions that are currently available. So I think the academia folks here must be thinking about this as a problem.
Thank you. One of the what I see in the academic solutions from nowadays is that when they change an environment from a source environment to a target environment, they always build a meta model so that they can validate that the target environment can conform to the meta models that they expected. And do you have any comment on this? I can refer to the Moda Cloud projects, the Europe projects, that they built an adaptive cloud environment where the source and the target environment conform to a meta model.
No, I'm not aware of that. That's very interesting. So thank you for sharing, but it's let's follow up. I really love to.
I mean, it's part of a forward engineering process to build a meta model to conform to.
Mm-hmm. The only comment on that is just the notion of the two on the two approaches to automation. And one of that is at the hype right now, and the workflow-based approach is off the cycle right now, and I call them declarative and imperative. And right now, when you look at, like anything from Heat and OpenStack to Puppet and Chef and Safe Engine into Kubernetes and a bunch of policy-based things, I say like, I don't want to actually direct on how things will get to normal. I just want them to be so. Like, here is the Kubernetes cluster. I want 4 instances all the time, and I want the connectivity. System go figured out. So this is, and the workflow type of approach is more the imperative approach, is more the, like, I want to take this complete kind of list of the steps. And the first one, the declarative, is more model-based. And as you can see in the imperative approach, there is less of the models here. It more follows the intuitive thinking, and that is why it makes it easier to automate the processes as they're run by people. So there is a whole bunch of, like, short is I see them complementary. And when you peel out, you will see that many of the declarative approaches has an imperative implementation.
I'm concerned about the security aspect. For the workflow engine to be able to perform these actions, do you have any better story on that than you need to put super admin credentials with incredibly high access for everything into the host where the workflow engine is running?
Well, there are at least 3 levels. Like in practice, we see at least the 3 levels of the safe checks here. One of the safe check is, of course, like workflow engine itself. Second safe check is the actions, because workflow engine only says like run this, run that, run this, and at least when like we architected that, the access control, the role-based access control is at the level of actions. Can you or impersonate it through the workflow, because when execute workflow, I execute as me, whoever started workflow. Can I have this action? Do I have an execution rights on this action? That's the second one. And the third one, I mean, these are very dangerous systems. They're dangerous systems because they change your infrastructure, period. Like anything that changes infrastructure is dangerous. Just side note here, the troubleshooting or removing false positives are less dangerous. The remediation workflows are very dangerous, so you can even level them up here. That is why, that's one of the reasons you don't see much of this system, like StackStorm is an on-prem installation. There is a software called Neptune.io that's trying to do that off the cloud, but that's the tension. Because when you try to do that on the cloud and manage that from the cloud, well, that doesn't get as much traction kind of industry as it's like I think because of this very reason. So people are skeptical. Anyone else? So thank you again.